please be seated and make yourselves comfortable. What a wonderful day it is. So I'd like to welcome everybody. Welcome to the graduate students who have worked, the new graduates who have worked so hard to get to this point. Welcome to our graduate awardees and some of our PhD graduates, and also welcome to the faculty. It's wonderful to be here at such a wonderful life cycle event such as this, and please enjoy. So I especially want to congratulate the undergraduates. This is the focus of our ceremony today. And you've succeeded in a long slog to your undergraduate degree in a field of physics, a very unique field. And the point is that every graduation, people are going to say, your field is special. But I want to propose to you that physics is more special than everybody else for a very good reason, which is that in many fields of knowledge is understood as learning something, being able to regurgitate facts, to being able to persuade on the basis of argumentation. We are a very different type of organization because we are definitely not a faith-based organization. We are an organization that's based on facts, logic, deduction, coming with new theories, new understanding of the nature of the universe. So another important aspect of the kinds of things that make a physicist unique is that in addition to trying to synthesize and come together and make a description of the physical world, it is based on a quantitative understanding. One can always wave one's hands and say various vague thoughts about how something should happen, but it's we who are physicists who try and make a quantitative understanding of the universe. And this kind of quantitative understanding is embodied by a very famous problem that was invented by Enrico Fermi. And so for the students, they'll know who he is, but he was a legendary physicist. He was in the middle part of the last century. He was known as a great experimentalist and theorist simultaneously. He developed the first controlled fission reaction at the University of Chicago in 1942, which was the harbinger of the Manhattan Project. And he invented this kind of problem called the Fermi problem. How many piano tuners are there in Chicago? And so for the non-physicists, this sounds like, what a dorky question. Who cares about how many piano tuners there are in Chicago? And when I gave this problem to my freshman physics class about 15 years ago, I got excoriated by them. They say, it's not in the book, it's not a very well-defined problem, why should we care about this anyway? But for the physicists in the audience, you recognize immediately that this is a very deep problem, because it's not fully imposed. One has to use power of logic to try and come up with how to make the right assumptions and ultimately come up with the right answer. And so at the end of the ceremony, you'll tell me how many piano tuners there ought to be in Chicago. But in addition to the frivolous, these sorts of quantitative reasonings based on pure thought can then answer much more deep questions, such as, how much energy do we need for everybody in the world to have the standard of living that we enjoy here in the United States? How much will it cost to send a mission to Mars? How much will it cost? How much energy will we need to send a mission to the nearest star in a time scale that's less than thousands of years? How quickly does the ice grow on the pond in the wintertime? How soon can you skate? So some of these questions are frivolous, some of these questions are important, but they all can be addressed by the techniques in physics. And another important thing that I just want to emphasize is this notion that with the techniques and approaches to physics, one can break the bonds of faith-based dogmas. 500 years ago, people believed that the Earth was the center of the universe and that planets revolved and the sun revolved around the Earth. And it took physics-based reasoning to show that it was the other way around. And it was an idea that had to fight a lot of resistance to get to that point. About 120 years ago, it wasn't clear that atoms existed. And many people fought bitterly about, did atoms exist, did atoms not exist? There was a lot of philosophical debate about this point. But eventually, atoms were found to exist. Once atoms were found to exist, then we looked at the internal constituents of the atom, and we realized there's something called a proton, and it was thought to be one of the fundamental elementary particles of matter. And ultimately, it was found that, in fact, the proton is also a composite particle that's made up of quarks. And so on it goes, that what we think as natural dogma today, the facts of the universe, get upended. And they get upended if you leave behind faith-based dogma and use the power of thought and the techniques of physics to try and analyze the system rationally without any preconceptions, and just take the theories and the experiments, where the data leads you, where the consequences of mathematical theories lead you. So again, I congratulate you on your achievements thus far, and in a few minutes we will be awarded your degrees, and that will be the fun part of the ceremony. But first, I have the honor of introducing to you our convocation speaker, Professor Sheldon Glashow. He's a Metcalf Professor of Mathematics and Physics at Boston University. He has many awards and honors to his credit, and notably the Nobel Prize in Physics in 1979 for his contributions to the unification of electromagnetism and the weak interactions of the elementary particles that he shared with Shelley Glashow and Abdus Salam. He has been a presence in our physics department since the mid-'80s and joined us full-time in the year 2000. And so it's my honor to introduce Shelley Glashow to you.
You may need them again. Yeah, I have to switch my glasses too. Yes, ladies and gentlemen. Oh, I have other things I could read, but I shouldn't read that. I have a title, A Physics, the Best of All Majors. Physics, ladies and gentlemen, physics is sometimes spoken of as the queen of the sciences. Today, I have the honor and the pleasure to welcome some of her most recently anointed subjects, as well as those we now shall designate as doctors of science, along with their families, their friends, and our faculty. Well, some of our faculty. Having mastered the study and practice of physics, we hope, our new graduates are now prepared to pursue virtually any career. Most of you, of course, you in the front row, aim to be practicing professional physicists working in industry, government, or academia. You may address societal problems, issues such as clean energy, climate change, sustainability, or you may create useful, valuable, or merely fascinating new substances, new materials, or study the sciences of, well, there's so many, surfing or sailing, or investigate the behavior of matter under peculiar conditions of high pressure, high energy, high temperature, deep within stars, in the depths of space, wherever. Now or later, some of you may find yourselves doing something slightly different, perhaps geology or chemistry or astronomy or ecology or computer science. Or you may wander off, some of you, into law, medicine, economics, journalism, business, or, heaven forbid, again, finance. And in all of these, an understanding of physics and math is very important, and increasingly so. On this very unusually lovely spring day, our doctoral candidates, I know this ceremony is mostly featured on the front row, but we have a few people getting doctorates as well, and they will magically morph from subservient graduate students to threatening competitors. Of our marvelous undergraduate honorees, 30% of whom are women, which is higher than the national average of 21%. In any case, 1/3 of them plan to go on to earn doctorates in physics. Another third, roughly speaking, insofar as you can divide 23 by 3, another third will attend graduate school in related fields, which include computer science, computer engineering, mechanical engineering, biomedical physics, and astronomy. And of the rest, some have found promising jobs, some are still looking for jobs, and a few had the audacity not to respond to our questionnaire, so we have no idea. In some quarters, many I would say, physicists have a rather nerdy reputation. In truth, some of them, like me, may well be nerds, but we are often highly cultured nerds and deeply involved citizens. Einstein, for example, enjoyed violins, sailboats, and was politically active as well. MIT's faculty usually includes one, sometimes two string quartets. My friend Lisa, she's a theoretical physicist out of some small school across the river. Lisa wrote an opera and had it performed in Paris, where it had lousy reviews, and again in Barcelona, where it had rave reviews. A physicist, a theoretical physicist writing an opera, it happens. Other physicist friends of mine have been part-time poets, published poets, painters, published playwrights, novelists, sculptors. The one-time leader of Fermilab has a marvelous sculpture in the Science Center at Harvard, which I suggest that you all take a look at. It's quite beautiful. Don't get your head stuck in it. Another colleague of mine south of here is producing a full-length movie, feature film. Some physicists, not too many of them, become politicians. One is the Chancellor of Germany, busy leading Europe astray. Another was the President of Kyrgyzstan, until he was arrested. And another was recently re-elected to our House of Representatives. He was, I guess he no longer is, a high-energy physicist. Some physicists become astronauts, some become submariners, where they know how to operate the nuclear power plants in the submarines. Others get into science and math education. Still others become experts in arms control, or global warming, or searchers for secret passages in the Egyptian pyramids. That was a buddy of mine, now deceased, who proved that there are no such secret passages by studying cosmic rays. Wally Gilbert, who was my good friend while I was a graduate student at Harvard, was once a promising theoretical physicist, professor of physics at Harvard. He then became an even more promising biologist. And then he became a Nobel laureate in chemistry. And then he was the co-founder of Biogen, a rather large pharmacological firm. Consequently, he then became a wealthy philanthropist, and now he's a well-reviewed art photographer. Well, you could aim for a career like that. But the best part of being a physicist, truly, is simply that physics is fun. In fact, one of my Harvard teachers, recently retired, just wrote a book. And the book is called, is his rather boring autobiography, but it's called Physics is Fun. Physics can blur the line between work and play. My father, who was a plumber, wanted his children to choose careers, unlike plumbing, where they could enjoy their work. When my father came home at night, the first thing he had to do was take a bath. I followed his advice, and I so advised my 4 children. They all have very happy, chosen careers, but none of them majored in physics. You did. Speaking for all of my colleagues, and wisely I would say, speaking for all of my colleagues, those here and those absent, I would like to thank our students for all their hard work and their persistence, their parents for their love and generous support as well. But mostly I would like to congratulate all of you on this wonderful occasion. Enjoy the day. Thank you.
Thank you, Shelley. Thank you for a very nice address, and thank you for pointing out to me that some of our faculty members are not here. Now we come to the fun part of the ceremony, which is the main part of the ceremony, which is to recognize all of the graduates and honorees. This ceremony is primarily focused on you, the students receiving the bachelor's degrees. But we also have a large graduate program, and I want to take a few minutes to recognize some of the graduate students who are here, the graduate honorees and graduate PhD recipients, in the sense that we can do this now in a more familial setting, because last night the PhD graduates received their PhD hoods in a rather large ceremony that included the entire graduate school, but at least now we have the chance to embarrass them among the physics family. So I'd like to begin by first recognizing some graduate awardees. And so these are the men who arrived without robes because they're not graduating, but nevertheless they are people who are playing a large role in our department. And so I want to first mention our first awardee who was received this award, the Gertrude and Maurice Goldhaber Award in Physics. This is an award that's given out, and so I want to first ask Tom Idakola to please stand and be recognized and embarrassed. This award has been in our department for 25 years. You're not allowed to sit down yet. It's been in our department for 25 years, and it is traditionally awarded to a graduate student who excels the best at research during his first year of graduate study. Tom has done more than excel. He has essentially led a collaboration that has recently published a paper in the most prestigious physics journal, Physical Review Letters, while he was still a first-year graduate student. So I overheard him at one point talking about getting his paper accepted. Oh, and by the way, homework number 9, when does it due? I think maybe I kind of screwed up on that. So it's really quite a testament to you to get to that level of achievement, or it is a first-year graduate student, while still juggling everything else you're doing, the final exams, and homework problem things. So congratulations to you, Tom. The second person that I want to recognize is Clint Richardson. So Clint, please stand and take your lumps. So Clint won the Teaching Fellow of the Year award this year. We have a very large undergraduate program. We teach roughly 1,100 students per year, primarily students taking engineering classes, pre-med classes, and freshman physics. So we have a large army of graduate students who assist as teaching fellows in these classes. And in fact, we have a number of really dedicated teaching fellows who do wonderful work. And so it's actually very hard to decide who is the best. But Clint has been a devoted teaching fellow for 2 years. He was already well recognized last year, and we recognized him this year for his wonderful contributions to teaching. Everyone extolled his dedication, his enthusiasm, his patience, his love of physics, and to try and impart that to the students. So congratulations to you, Clint. Our last awardee is Alex Kitt. So Alex has been awarded the Alvaro Caro Prize for overall excellence in research and physics. This prize is named for former graduate student at Boston University, Alvaro Recaro, who was truly a wonderful and magnificent person. He was a student in one of my classes. I really enjoyed him, very enthusiastic, very smart, on his way to a great career, and tragically died just for reasons we don't understand. He died at a young age while still a graduate student, and so we've endowed a prize to try and memorialize his attitude towards physics and his contributions to physics, and we name it and we honor the best research achievement overall in physics in our graduate program. Alex Kidd is an experimentalist. His research advisor says that this is the best student he's worked with in 25 years at Boston University. He's done groundbreaking work in understanding the physical properties of graphene, this wonderful two-dimensional substance that, if you haven't heard about it yet, is going to take over the world pretty soon, and everything will be graphene. And so keep your eyes open for it if you haven't heard about it. And so Alex has made some great contributions to this field. So congratulations, Alex. Now let me spend a couple of minutes also recognizing our PhD awardees. We had 14 PhD graduates this year, and typically that's how many we have. Many of them, though, because there's not like final exams and then people are here to graduate, many people defend their theses all throughout the year, and many people start their careers at strange times throughout the year. So of the 14 graduates, only a few of them happen to be in town now, because many are already off beginning their research careers. So we're fortunate that we've been able to persuade 3 of them to come, and some of them are already starting jobs and have to fly back to their jobs almost immediately. So let me just begin in order first with Shuqing Wang. So he came to Boston University from the most prestigious, one of the most prestigious universities in China, the University of Science and Technology. He got his PhD last spring. He's been working in the theoretical development of complex networks and the application of complex network models into economic systems. So as our Professor Glashow was mentioning, finance seems to be a very nice parking place for people to have great careers after a degree in physics. So after graduation, he's working in the research department at Bloomberg Company as a quantitative financial software engineer. His interest is in financial data and analytics, modeling, and understanding trading data and trading news. So congratulations to you. Song Bo Jin. I just attended this man's PhD defense a few short months ago. Songbo works in condensed matter theory with a main focus in understanding the phase transitions of quantum and classical many-particle systems by megascale simulations. So they have huge computers that run months at a time to try and understand the basic properties of matter under unusual conditions. After graduating from BU, he took a data scientist position at Little & Company, which is in the payments, processing, and intelligence industry. So he's performing quantitative research using large data sets. That's another big buzzword these days, big data and understanding big data. He's doing fundamental research behind new and existing data products. He's identifying newer opportunities for e-commerce merchants to grow revenue and reduce costs, and provide scientific support across all departments in his company. And so he's using very well his background in Monte Carlo simulations and large data analysis to do this interesting work that hopefully when he's financially very successful, will remember us fondly. And then our last PhD awardee is Erica St. Clair. So I remember Erica fondly as a student in my statistical physics class some time ago when her last name was a different last name. And since that time, she has gotten married, she started a family, she has done wonderful research in biological physics, and in the meantime, she had all kinds of other side gigs. This is a very ambitious and talented woman. She developed a photography business. She was interested in running marathons. She was doing all kinds of other work in all different fields. This is a woman who essentially, I don't know how you sleep ever. I don't see how it would actually happen. Just a little bit. So she is now pursuing a career in commercial photography. It's one of many things that she does interestingly and very well, and so congratulations to you. Okay, so now we turn to the main event, the awarding of the undergraduate degrees. So let me just tell you a few preliminaries before we actually award them, which is that we have a professional photographer on hand to take pictures, but if family members want to come up and take pictures, people are going to be called in alphabetical order, and so if you want to come up just a person before and get yourself situated, I guess I will be here giving you the award, and I will be here to shake the person's hand. Award there, so you can get in position and feel free to do so. There'll be only one person who's out of alphabetical order because, as you'll hear in a moment, this person actually has to have 2 degrees and is going to 2 different convocations that are more or less at the same time. So let me ask for the undergraduates to please stand up, line up, and we will call you in order. And if anyone, so please go ahead. And so if anyone wants to start getting ready with their photography equipment, call Rob Perry, the Director of Undergraduate Studies, who will actually be awarding the diplomas. Okay, so let us begin then with the formal awarding of the degrees. So I'm going to first call the student. Please stand here while I say something about you, and then you get your degree. So our first student is out of alphabetical order, Kripa Patel. Why is Kripa out of alphabetical order? Because she's also getting a degree in the engineering college, and their convocation begins at 10 o'clock. So she's got to rush out of here more or less after she gets her degree. So it's too bad you're not here for the whole story, but we will miss you, but we understand. So Kripa was awarded a trustee scholarship, which is the highest undergraduate scholarship available to undergraduates at Boston University. She's graduating cum laude, and she's made the dean's list. She began her research at BU at a cancer research lab at the medical campus. She's also participated in the Geneva Study Abroad program at CERN, the Large Hadron Collider at CERN, which is the largest high-energy physics lab in the world. And you'll hear other students who participated in this program. She's currently working in a biomedical optics lab doing a biomedical engineering senior design project in cancer diagnostics. After her graduation, she hopes to work in a biomedical optics laboratory, and she hopes to then continue graduate study in biomedical engineering. So congratulations. Our next graduate is Daniel Akara. So Dan has worked in the research laboratory of Professor Rick Avery, performing terahertz spectroscopy. This is a very high-frequency spectroscopy of trying to probe the internal structure of matter at the smallest scales. And he's also been working on nonlinear optics phenomena. Unfortunately, or fortunately as the case may be, we've not been able to get rid of Dan. He is a very sociable guy. He is the photon advisor. He's been everywhere in assisting with high school open houses. He's been a wonderful social presence in the department, and he is returning to graduate study in physics at Boston University this coming fall. So congratulations. Our next graduate is Kelsey Bilsbeck. So Kelsey gets a major in physics, and she also has a minor in mathematics. So she's had a lot of research experiences, and I should also emphasize here that one of the things that we pride ourselves on is to get our students working in research labs. So many of you have been involved productively in research labs. So she has worked as a research assistant in the Computational Mechanical Engineering Energy Lab and in the Biomedical Engineering Lab. She also participated in the CERN Geneva program and learned French, I think. A little. And she also participated in the Physics Department Learning Assistant Program, which is a new program developed recently in which advanced undergraduates essentially work as TAs, helping freshman physics. And we find that sometimes having peers help the students is a lot less intimidating, and she's done wonderful work in this area. After she's graduating, she's going to be pursuing a PhD in mechanical engineering at Colorado State University at Fort Collins, and I bet you she might even do a little bit of skiing. Congratulations. Our next graduate, Brian Oruki. So Brian is a major in physics and a minor in computer science. Many of these guys are doing many different fields of study. So he's currently working as a research assistant with the Computer Science Department Computer Vision Group. This group is stereoscopically tracking and modeling the flight trajectories of bats in order to advance visual tracking technology and also to analyze group behavior. It sounds like a truly fascinating subject. If you've ever seen a cloud of 300,000 bats moving at once, I wonder how you actually do it. After his graduation, he's going to continue performing research and will pursue a master's degree in computer science. Next graduate, Claudio De Mutis. So he has a major in physics, a major in economics, a minor in mathematics. He was a CAS scholar. He made Dean's List in the spring of 2011, a member of the Sigma Alpha Lambda National Leadership and Honors Organization and National Science Society of Collegiate Scholars. For his research experience, he spent a lot of time in Professor George Zimmerman's lab investigating superconducting and radioresistive materials, and he also worked at the BU Institute for Astrophysical Research. He's going to be pursuing a Master's of Science degree in Computer Engineering after his graduation. Our next graduate, Josh Gray. So Josh is a straight physics major, and he also participated in the CERN Geneva program. And during his period there, he worked in the research group of Dr. Ugo Amaldi, who has founded this Terra Foundation, which has developed carbon beam therapies for developing carbon beams for cancer therapies. And so Josh was involved in the magnet design for focusing these beams to optimize their utility. And after graduation, Josh is continuing his interest in biomedical and medical physics. He will be pursuing a PhD in medical physics at the Graduate School of Biomedical Sciences that is jointly run by the MD Anderson Cancer Center and the University of Texas. So, our next graduate, Shamafi Hassan. So Shamavi has a major in physics and minors in chemistry and electrical engineering. She is graduating cum laude. While at BU, and this I really don't understand how you did this, you'll have to explain it to me. She worked with Professor Fukuyama at the University of Tokyo on the effects of magnetic fields and temperature on transport properties of exfoliated graphene with nanoholes. Over the summer, in Tokyo. Wonderful. She also has been working with Professors Anna Swan in the engineering and the electrical engineering department and Dennis Goldberg in our physics department, understanding graphene spectroscopy here at the Photonics Center. After graduation, she'll be working as a healthcare software company at a healthcare software company as a programmer and technical analyst here in Boston. So congratulations. Our next graduate, Ishan Kabir. So it's a little bit of a personal note here because due to the vagaries of the teaching schedule, there's sometimes that I know all the graduate students intimately, the graduates intimately, because they've all been in 3 or 4 of my classes. This year, I've only had the pleasure of knowing a few of you in your classes, and Ishan is one of them in my quantum mechanics class. Suffered through it, I'm sorry. She graduates with a major in physics and computer science and a minor in mathematics. She's graduating magna cum laude. She was also awarded UROP funding 3 times. UROP is the Undergraduate Research Opportunities Program here at Boston University to get undergraduates involved in research. She's worked in a nanotechnology lab exploring the properties of graphene. She also worked in the computer science lab developing an iPhone app for doctor-patient interactions for Boston Medical College. And after graduation, she'll be working as a software engineer at an IT healthcare company. So congratulations. Next graduate, Mark Hornbluth. So Mark graduates with degrees in astronomy and physics. For the past 2 years, he's been studying the effects of stellar heating on the mass loss rates of stars. After graduation, he's going to be taking a year off to hone his research skills, and to prepare for a potential graduate school career, and hopefully he will find himself along the way as well. So congratulations to you. Our next graduate, Dasam Lee. So Dasam is graduating summa cum laude in physics. And I have to say, I actually made a little bit of a mistake, which is that I forgot to recognize, in particular, the undergraduate awardees at the level of the physics department. So I will make a little bit of a detour here, that Dasam is also the winner of the College Prize for Excellence in Physics, which is one of the top 2 prizes that we in the physics department offer for overall excellence in both academics and in research. Our second awardee here, so I've asked Claudia to please stand up because I forgot to at least give him those kudos, is that he won the Alumni Award for Achievement in Physics. So these are our top 2 undergraduate students in overall achievement in academics and in research. So congratulations. And turning my attention back to Dasam, she is graduating summa cum laude, as I mentioned. While at BU, she performed research with the particle physics neutrino group. She also studied abroad in Geneva. She was working with the CERN mice collaboration. In high-energy physics, the physicists tend to have all these strange acronyms for their experiments. So it's supposed to be something easy to remember. Mice is easy to remember because you don't want to catch it. But mice stands for something important, muon ionization cooling experiment. And so she worked in this experiment and helped develop the detectors for this experiment. And so after graduation, in fact, what she's doing right now, she's working at the Museum of Science in Boston. So congratulations to you. Our next graduate, DJ Levens. So he has a major in physics, a minor in computer science. And so he also worked on this mice experiment, muon ionization cooling experiment, while he was doing research in the CERN program. He was tasked with testing and analyzing photomultiplier tubes used by the electron-muon ranger, scintillation calorimeter designed to slow muons, electrons, and ions. After graduation, he is looking for jobs in scientific industries. He's planning to gain a few years of experience and then pursue graduate student in high-energy physics. Congratulations. Our next graduate, Cesar Matos. Cesar obviously has a great cheering section. He graduates with a major in physics. Cesar actually has found himself during his undergraduate years, and he actually hopes to work in the medical field. He's working currently at the Arbor Hospital in Jamaica Plain as a mental health worker. And he's found the humanistic side of himself, and he likes to be with people, and he's planning to do, I think, very important work, because my wife is a nurse. He's planning to go to nursing school and to pursue a career in nursing. So I congratulate you. Our next graduate, Kevin Ruiz Miranda. So Kevin has majors in astronomy and physics, pure and applied math. I don't know how you fit that all in 4 years. While he was at BU, Kevin has worked with a variety of research groups. He worked in the group studying stable auroral red arcs research group and the BU student-built satellite project through the Center for Space Physics. He was also a research assistant in the astronomy department. He also participated in the CERN Geneva program and worked on the NA62 experiment, trying to understand the properties of kaons. These are schizophrenic elementary particles that can't decide what they are, and they change their type from K long to K short spontaneously and do all kinds of weird things. It's part of what makes physics so amazing. So after graduation, he will be pursuing a master's degree in physics at the Swiss Federal Institute of Technology in Lausanne, Switzerland. And after obtaining this degree, he plans to return to the United States for a PhD in physics. Next, Max Porter. Max is graduating magna cum laude in physics, with a major in physics and a minor in philosophy. That was my worst subject as an undergraduate. I don't know how you do it. While at BU, he worked with Professor Michael Abbat-Nooney on his topological insulator experiment using helium atom scattering to probe the properties of the surfaces of these topological insulators with high precision. This is a very weird material, which is an insulator, except on the surface where it's a conductor. It's just, if you haven't heard about it, you will be hearing about it 10 years down the road. He has also worked with Professor Becky in the Computer Science Department on the video analysis and tracking of colonies of bats in flight. So after graduation, he's planning to continue his research while he takes off a year before applying to graduate school. So congratulations. Our next graduate, Kevin Roberts. So Kevin graduates with a major in physics and a minor in astronomy. He's a very understated young man, and we worked hard to elicit from him some information about what he's doing. So he is obviously looking to find himself to some extent. He plans to live in Boston, take a year off, study for the GR exams, and prepare himself for graduate school in a computer-related field. So good luck to you and congratulations. Our next graduate, Joseph Semenienko Evans. Major in physics. This man, I remember when he showed up as a freshman because he was my advisee, and it just seems like he's gotten taller in the 4 years that he's been. So while at BU, he's performed research with Professor Pankaj Mehta on biophysics. He also participated in the Geneva Study Abroad program, being involved in many different experiments. After graduation, he's planning to pursue a PhD in physics at the University of Colorado in Boulder. Joseph also has another career. He has a career as a firefighter in the California forests. And so at this stage, the overprotective Jewish parent mothering me cannot help but say, big shot. Towards the fire you run? Try running the other way. So I'm very impressed with your bravery and all your achievements, and I wish you all the best. Next, Alexander Sirota. So he graduates with a degree in physics and mathematics. While at BU, Alexander researched circuit design to measure magnetic properties of superconductor in George Zimmermann's lab, and he also did simulations of superconductors in his lab. And after graduation, he was pursuing a PhD in high energy physics at the University of Virginia. So congratulations. Next is Aaron Sternbach. So Aaron has been working primarily in Professor Rick Averett's lab over the past 2 years. He's been exploring the physics behind correlated electron materials, liquid crystals, metamaterials, semiconductors, and more. He's co-authored 2 publications and also patents. Before working for Professor Averett, Aaron was a research assistant at the Center for Space Physics. And I have to say that I first met Aaron when we were doing a GRE prep session, and I remember him being the most enthusiastic student, working out the problems, going, yes, I got it. After graduation, Aaron will be pursuing a physics PhD at the University of California, San Diego, and I get the impression that he might even take a surfing lesson along the way. Next, Trey Linder. So Trey has majors in astronomy and physics, and he has been parallel to our other 2 awardees. He's been awarded the College Prize in Astronomy for the best achievement in the astronomy department, and he's also been awarded the Institute for Astrophysical Research Prize. He is graduating summa cum laude and is a Phi Beta Kappa inductee. He's been working with Professors Banya and Brainerd in the astronomy department. He's also worked at the National Astronomy and Ionosphere Center and at the National Radio Astronomy Observatory. After graduation, Trey was awarded a prestigious Jefferson Fellowship to attend the University of Virginia and intends to pursue a PhD in astronomy. So congratulations. Next, Russell Wilcox Klein. So he has majors in physics and earth science. When he came to BU, he began research under Dr. Colleen Dalton of the Earth Sciences Department, and it was investigating the Earth's structure using seismic waves generated by earthquakes. Russ has also been a learning assistant since the program started in the fall of 2011, and we're very grateful for his good work in that field. After graduation, he's planning to take a year off to prepare for grad school applications, but he's not going to be just lolling about. During this time, when he's going to be preparing for the GRE, he's going to be teaching music privately and performing professionally with his jazz ensemble, the Russell Wilcox Jazz Group. And last, but not definitely least, is Ashley Wright. Ashley graduates with a major in physics, a minor in music performance with a concentration in clarinet. She made the dean's list for the past 5 semesters. For the past 2 years, she's been studying the causes and effect of the midnight temperature maximum in the ionosphere with Professors William Oliver and Carlos Martinez in the Space Physics Lab at Boston University. After graduation, she has a summer job as a resident assistant at the BU Tanglewood Institute, and after that, she'll be looking for jobs in the Boston area in who knows what field. It seems like you have yourself an open camp. So we've come now to the end of our ceremony. All that's left is just a few last thank yous. So I just want to tell everybody that what we will do is we'll have just a few minutes of thank yous all around. We will then march out in the opposite order in which we marched in, and then everybody's invited to the reception following. So what I'd like to do at this stage is that I want to ask the undergraduate, the bachelor's graduates to please rise. And again, I congratulate you on the long slog that got you here. Sometimes it was rewarding, sometimes it was boring, sometimes it was exhilarating, sometimes it was difficult. I hope you had a great adventure here. I hope you'll remember us fondly in whatever you're going to do. And along the way, in order to get to where you are, you had to take classes, you had to work hard. Maybe some of you slacked off once in a while, but not too often, because I saw how hard so many of you worked. But it was your professors who helped guide you to this direction. So I'd like to ask you to do is to please turn to the faculty and please thank them for all that they've done for you. You also should be recognized for all of your achievements, for performing problem set N and N+1 and 3 problem sets in a row with 2 midterms the same day. So I'd like to ask the faculty to please stand and thank the undergraduates for being such good students. And finally, most important, you are here because not just yourself, you're a part of a family, you have loved ones who help guide you, who help sustain you, who help nurture you. I'd like you to turn around now and face your family and your loved ones and thank them. So this concludes our ceremony. I guess we're going to begin the music and the processional out with the undergraduates first, the graduate students and the faculty, and then you are all invited to join us for reception outside.